begin, we're going to go over different types of isometric transformations. In the previous video, we went over a translation. A translation is simply moving a figure left, right, up, or down. This is our notation, or our instructions for translating a point. Here's our point, and then we're going to have instructions over here with a number behind the X and a number behind the Y. The number behind the X is going to tell us to go left or right. The number behind the Y is going to tell us to go up or down. Our next type of transformation is going to be a rotation. Now, a rotation is when you take a figure and turn it about a certain point. Now, that certain point that you're turning it around is called the center of rotation. Now, all rotations you will do in this class will have 0, 0, or the origin as the center of rotation, and we will only rotate a figure either 90 degrees, 180 degrees, or 270 degrees. Each of these measures represents one quadrant. So let's take a look as an example of me rotating a figure for each one of these angle measures. So we're going to go over each one of these rotations, the 90-degree rotation, the 180-degree rotation, and the 270-degree rotation. On each of these, the center of rotation will be the origin, or 0, 0. So we're going to take this triangle and we're going to rotate it 90 degrees. So let's do that. Let's rotate this triangle 90 degrees. Here's what it looks like when we rotate it 180 degrees. And then here's what it looks like when we rotate it 270 degrees. If we continue to rotate different figures, after a while we'll come up with a rule. Here are our rules for each one of these angle measures. The 90-degree rule is this. If we take a point and we rotate it 90 degrees, the new point will have the X and Y coordinates switch positions, and the Y will turn into the opposite. If it's 180 degrees, the rule is the X and Y will stay in the same place, but I write down the opposite of those numbers. Meaning if it was a positive 1, it would change to a negative 1. If it's a positive 9, it will change into a negative 9. The 270-degree rule is if I take that point and I rotate it 270 degrees, the X and Y positions will switch, and then I will write down the opposite of the X. Here's a screenshot of the figure that I was rotating before. I rotated this figure 90 degrees. Let's see if our rule works for each one of these points. Let's see what point A is. The coordinates for point A, I go over 4, but I don't go up any. The rule, the 90-degree rule, tells me that for every point, if I rotate it 90 degrees, the X and the Y are going to change positions, and I'm going to write down the opposite of that Y. So let's look and see if that takes place with this picture. My A got rotated up to this point right here. What are the coordinates for this new A up here? Well, I don't go over any, and I go up 4. Let's see if it followed the rule. The X and the Y switch positions, and the reason there's no negative on this is because 0 is not positive or negative. Let's see if C worked out. The C starting off is right here. That would be not going over any and up 3. My new C coordinates, following this rule, I should change positions and the Y should be the opposite. So let's look and see. My C started here, got rotated down here. The new coordinates are -3 and 0. So did the X and the Y switch? The X and the Y switched, and then I changed the sign, or I wrote down the opposite of my Y. Let's see if my rule holds up for 180 degrees. My rule for a rotation of 180 degrees is this. I'm going to take a point, and when I rotate it 180 degrees, the X and the Y stay in the same spot, but I write down the opposite of each one of those. So let's look and see. I'm going to check point A. A started off again at 4, 0. And when I rotated it 180 degrees, let's check out the new coordinates. I rotated 180 degrees. My X is -4. My Y is 0. The X and the Y did not change positions, but the sign changed. If this had been a number that was positive or negative, I would have had to change the sign of it as well. C. Here's my starting point for C. It is 0, 3. I'm going to rotate it 180 degrees, and I'm going to determine what the new coordinates are for C. That means the X and the Y stay in the same position. I don't go over any, I go down 3 and check my rule. The X and the Y stay in the same position, but I write down the opposite. My rule is applying for this 180 degrees. The X and the Y stay in the same position. I just change the signs of my X and my Y. Let's see if the rule works for 270 degree. The rule for rotating something 270 degrees is this. I'm going to take my X and my Y, and when I rotate it 270 degrees, the X and the Y change positions, and then I write down the opposite of the X. So let's check A. A started off at 4, 0. And when I rotated it 270 degrees all the way around here, my new coordinates for this point right here, I don't go over any, and I go down 4. Did it follow this rule? Yes, the X and the Y switched positions, and then I had to write the opposite of X. Let's see if point C follows the rule. Point C started off right here. I don't go over any, and I go up 3. When I rotated it 270 degrees, when I rotated this point 270 degrees, I need to find the new coordinates for this point right here. The new coordinates are 3. The X and the Y switched, but I didn't have to change the sign of the Y. So my rule is holding up. So what we're going to do is we're going to take each one of these rules for rotating a point around the origin. We're going to take the 90-degree rule, the 180-degree rule, and the 270-degree rule, and we're going to see what this point, the new coordinates for this point would be once we rotate it. So we're going to take this point and we're going to rotate it each one of these degrees. We're going to start with 90 degrees. Remember, the rule for 90 degrees is if you take a point and you rotate it 90 degrees, the X and the Y change positions, and you write down the opposite of Y. That's what that minus sign means. So we're going to take this point right here. The point is 8, -3, and when we rotate it about the origin 90 degrees, I'm going to switch the positions of the X and the Y, and I'm going to write down the opposite of this Y, because that's what that negative sign means. Write down the opposite. So the opposite of -3 is +3 and 8. That's what the new point is after I rotate it 90 degrees. The rule for 180 degrees is if I take a point and I rotate it 180 degrees, I simply write down the opposite of the x and the opposite of the y. So let's do that for this point right here. 8, negative 3. If I rotate it 180 degrees, I'm simply going to write down the opposite of each one of these. The opposite of positive 8 is negative 8. The opposite of negative 3 is positive 3. That's the new point after I rotate it 180 degrees. The rule for 270 degrees is if you take a point and you rotate it 270 degrees, the x and the y change positions, but I write down the opposite of my x. So my point is 8, negative 3. I'm going to switch positions with the x and the y, and then I'm going to write down the opposite of positive 8, which is negative 8.